Let's examine this on live equipment. ASW1. If we type in show spanning tree for VLAN 10, we can see that currently gigabit 0/1 is the root port, and that heads up to DSW1. We can see gig 02 is the alternate blocking port, which heads up to DSW2. So if we follow the root port, we go to DSW1, and we type in show span for VLAN 10, and we can see that the root port is gig 102. So going back down to ASW2. So right now the path to get to the root bridge is ASW1 to DSW1, then DSW1 back down to ASW2. Now you might be questioning, why is ASW2 the root bridge? Well, is it? Show span for VLAN 10. Yes, it is. It definitely is the root bridge, as we can see here. I would agree with you for saying that's not an optimal position. It's not, and that is a discussion for later on, not for now. But for right now, it's set up this way so we can see what happens in our transitions right now. So let's go to DSW1. We're going to simulate an issue. I'm just going to shut off interface gigabit Ethernet 1/0/2. And by shutting off this particular interface, spanning tree protocol is going to have to converge. It's going to have to find newer paths through the topology that can be utilized to get traffic from ASW1 over to ASW2. And I'm predicting right now, based on costs and calculations that spanning tree will go through, that gigabit 0/2 on ASW1 will transition to the forwarding state and be a root port. So traffic will then go from ASW1 to DSW2 down to ASW2. But in order to watch this process happen and see that it takes 50 seconds to accomplish, let's type in a debug command. Debug spanning tree events. Now let's watch this unfold. We'll go over to DSW1, shut down the interface between DSW1 and ASW2, which is currently the root port. And we'll go back to ASW1 and watch the magic happen. So look at the time. It says 26. 26. So it's going to take 20 seconds. So that means we should be at 46 when the gigabit 0/2 interface on ASW1 transitions to the listening state. All right, we were close. It was 44. I was off by 2 seconds, probably because I missed one of the BPDs. So it took 18 seconds in this case, because I didn't turn on my, or I didn't come back quick enough, let's say. And then from 44 to 59, well, there's 15 seconds. So we went from listening to, we spent 15 seconds in listening. Now we're in the learning state. And so when we get to 14 here, yes, there it is, we are now in the forwarding state. So if you examine this, again, you'll see that we started up here with 26 and 18 seconds later, pretty close to 20 seconds. We are now in the listening state. We spent 15 seconds in the listening state, and you can see we transitioned to the learning state 15 seconds later, and then we transitioned to the forwarding state 15 seconds after that. So remember those timers. 20 is max age timer, 15 for listening, which is the forward delay timer, 15 for learning, which is the forward delay timer as well. Let's go back to DSW1 and re-enable that interface. And I want to show you, again, this process, but in a different way. Oh, we got to shut off those debugs. Don't need the debugs on right now. So show spanning tree for VLAN 10. Notice here, gigabit 0/1 is the root port again. Gigabit 0/2 is blocking. Let's go ahead and shut off that interface. And we'll see on ASW1 that gig 01 is still the root. Gig 02 is still blocking. And this is for 20 seconds. So all traffic that is flowing for VLAN 10 up to DSW1 is going where? Well, that's the problem. You see, the black hole is being created here. Traffic is not going to get to its destination. And now look, gig 02 is the root in the listening state. But are we forwarding frames while we're in the listening state? No. Now we're in the learning state. Are we forwarding frames in the learning state? No. So during this 50-second dark period, users are going to experience issues related to not being able to access various resources within the organization. And now we can see that gig 02 is the root port in the forwarding state. So now we're stable for this particular topology, and everything will flow fine. But during that transition period, wasn't pretty at all. Took too long to transition. So that is why rapid spanning tree protocol is a better option than spanning tree protocol or 802.1d or per VLAN spanning tree plus, which all rely on these timers.